So, hello. Here is another demo of a database performance comparison. Here we're trying to compare the performance in both the MongoDB, which is a NoSQL database, and also SQLite database. So here you can see that we are trying to do this with the help of Jupyter Notebook, where we have written queries to perform CRUD actions or CRUD operations on a data set called a police data set that we got this from Kaggle. We'll see how we have created the tables and then what kinds of queries that we have performed and how their performance is in comparison with each other. Okay. Here is a simple ER diagram of the data set that we have. And this here explains how we have used SQLite and made a connections. We have SQLite 3 in Python that we made use of. So we just created a database file with this particular name, and we have tried to import all the data that we have in the form of CSVs into our database. And we have performed some simple and also some complex queries. Simple queries are basically queries on one single table, like you can see here. Yeah, like you can see here. Here we have like different types of tables, like city table, the race table, and another table called person over 25 completed high school. And we have inserted data once we created those tables by using these operations. So this particular file gives us how we created and inserted data into our tables. And here are the queries that we have used. So which is connected to the database. And then this is a simple query. And we'll execute the query and just print the result on it. So here are some simple queries, which are basically queries on one particular table. And here are some complex queries, which have joins and a lot more where conditions that would eventually increase the execution time of the particular queries. So here are some queries, some update queries as well. And one thing to note here is that when we run a query, we get one execution time, but this execution time is not the same every time we run that query on our computer. Although the query is same and the database or the data set on which it runs is same, we may not always get the exact same time for execution. That is due to the different computation power that is available while executing that particular query. So in order to avoid any of such errors, we made sure that we run every query for 200 times. Here we can see that the number of iterations. Here we have put 200, but you can put any number. And we have taken the average of all the execution times. That way we can at least be sure that that particular number is a representative of all the queries execution. And at the end, we have plotted this graph to show how indexing is making a difference on the execution time. So here you can see this orange one, the graph with the orange line is with the indexes and the optimizations, and the blue line is basically without the indexes. So for simple queries, you can see that, of course, for all the queries, you can see that having indices has reduced the execution time. So we already know this, just validated this. And for complex queries, we can see that there's a huge difference sometimes, but simple queries are equally effective with indices. So this is what we have found within our SQLite database. Now we are going to compare this with the MongoDB. So whatever the data set that we had and what are the queries that we've executed for this SQLite, we're trying to do the same with the MongoDB database. It's the basic same thing. We read the database, we create a database, and we import all the CSV files. Of course, we clean the data and insert it. And once we have this data inserted into our tables, we were then trying to run or execute the same queries that we have previously seen in SQLite. This is this almost similar thing. Again, here we're making use of the MongoDB client that's available in PyMongo, and basically the same queries that we have seen before. And when you run it, you can see that for with indices, there is a huge difference in simple queries. This is very much similar to what we have seen in SQLite. And for complex queries also, when we plotted the indices versus no indices queries, we can see that with indexes, the execution time is reduced. But they're almost like of similar range. But you can see the huge difference in between the indices, like having indices and not having indices on simple queries. So this is the proper comparison of the performance of these two databases, MongoDB and SQLite, with the dataset called police dataset. And we have done the similar comparison with another dataset as well, which is the Twitter dataset, the dataset that we have first proposed. Here you can see, here we are trying to basically install all the Twitter related data and do the Twitter, get the data from Twitter with @Nike, and we just read all the data into our CSV file. So these are the columns or attributes that we get from Twitter API, and they're all stored in a CSV file. And we are doing a bit of cleaning here, removing the filler words and all. And you can see that we can also give the polarity scores for each of the sentences or for each of the piece of text. And we use the NLTK toolkit and do some sentiment analysis. And we come up with the score for each of the text. And depending on the score that we get, we are labeling it as positive, negative, or neutral. So once we have the Twitter data set from Twitter, we are also appending the sentiment of it by doing some analysis. So at the end, so if you think this is the entire data that we get from Twitter, and this is the category that we have appended. So this is another data set that we have, and we perform the similar kind of comparison on the Twitter data set. So whatever we have done with the police data set, we have done similar comparison on the Twitter data set, and we can see that it also gives the similar results, like having indices is reducing the execution time of the queries. Yeah, thank you.